2. It's either 3 or 4 then, right? Because this is Bluetooth and it's off, whatever that is.
Again, we got about 3 minutes before judges come in. Should have that link. If you go to YouTube and Saint TV, you should be able to engineering machine design link. Good luck. 2 minutes.
So is that how you got, how did you get Travis there? Because there was always sound on the side of the station. How did he get it without this?
He would put this on the side.
This on the side?
Yes.
Can you do that?
If you guys don't have it.
Weston.
Check out the Resource Center if you get a chance. Good luck.
I'll call you. Come on.
Take a seat. Rather than sit on the stairs, stay the cabinets are bare, and I'm unaware of just how we got into this mess. Got so aggressive.
What's that? Yep. I don't know. It's a good question. But those are the same way. Same thing.
Those mini bikes. Are you buying it? Is that one muted? Oh, it's not.
I know. It's an idea. So go back to your audio. Are you guys live, by the way? Yeah. And let's play through. Is that checked? Neighbor. Now try it, Jace.
Hello. It says it's picking stuff up.
Can we connect this into there? Can I connect
connect this into here? So it's in the roadcaster?
Input plus sign USB.
It is now. Hello?
It's making stuff up.
So they can't hear it, but it works.
Yep. So you guys are live, sound and everything. What?
So just hold this.
So then you can take that and tape it.
Yeah, that'll work.
That's probably.
So with this boom mic, I can get the conversation like this. Get your camera here. So I can do it. Voice is quiet. We'll interview a Saints person first. You don't have to have.
All right, ladies and gentlemen, we're about ready to get rolling here. First, I'd like to thank and introduce our judges. We have Luke Forrest from Saint Ansgar Community, former engineer. Sam Heimer from KFS Electric. Bryce Gruska from John Deere. Richard Brown, Mitchell County engineer. Bill Rowcliffe from Hormel Foods. Sula Master, retired science teacher. Kay Straley from Central Rivers AA. Chuck Buston from Central Rivers AA, and Derek Howard from Wolves Rim and Tire. Thank you for judging today. We're going to follow them along in the senior division. We'll start down here with the St. Edmund senior team. We'll go down the line, come back this way, and finish with St. Ansgar in the senior division. Also, they'll see our junior team from Mount Air down by the stage. We'll go through the first time. You'll get to do your presentation for the prelim. The judges will go with a couple of their awards. We'll come back in, and then we'll go right into the finals. For the finals, I'll hand the microphone over for another presentation, and then you'll run it again right after that. Reset and run through again. All right, here we go. Coming down to St. Edmund.
So, where do you want me to?
Yeah. Ain't gonna be just
Go around it. Wait, making it those buttons go off?
I'm just getting away. That's Joe's.
We're going to slide down one to senior team number 6, West Hancock. Hey, psych. Rockford, team 5.
Oh. That's probably how we're working, right? Blue mic says it's working. Just carry this around.
So the purpose of our machine is to warn people when chemical reactions are about to happen and to catch the reaction.
This whole thing is made out of recycled materials from older physics classes that participated. So, yeah, it's all recycled stuff. We struggled with designing how to get the liquid into the flask. We had issues getting the right tube for the golf ball. We also had other problems along the way. How we modified those were
we had issues with the golf ball constantly falling off, so we put a guard here to keep it going down the tube, and then we added the 2 metal holders to hold the funnel in place. Ready? Yep. I'll wait for it to press this. It missed.
Totally missed.
All right.
I was worried about
Nice
the
job.
phone.
When we come back from the finals, we'll have some questions to ask when either before or after your presentation. So that'll be a little different the next time around, but otherwise we'll see you in a few minutes.
Okay, thank you.
That's what I was worried about.
So
You should have had something.
when it tears, it moves. So we'll have to.
What moves? The
All
flash?
right, we'll slide down this way now, back to West Hancock on this side of the gym.
Morning.
Morning.
I guess you guys can go ahead. We'll probably have some questions in the final presentation. After you run and give your presentation, we'll have some questions in the finals. But for now, just give your presentation, we'll watch, and then we'll see you in a few minutes.
Hi, we're from West Ansgar High School, and I'm Eden.
I'm Caitlin.
I'm Amelia.
I'm Mallory. I'm Whitney. I'm Sydney.
And I'm Evan.
And this is our project called the tape job.
The story of our Rube Goldberg machine is that it represents the human body. The red balloon inflates as the lungs do, the red liquid flows through the syringes like blood through the veins, and the heart is represented in the end by the light that is turned on. The wooden blocks represent the vertebrae, and the ribs are represented in the cardboard tube carrying the marble.
Our team used the engineering design process from working at the end forward. We knew our last step would be turning on a light bulb, so we worked from there. The 4 advanced components were key, and we researched on TikTok and YouTube. Our ideas that we found were based on trial and error, and we made small revisions as needed.
We used the integration of advanced components. Our first was the chemical reaction. Chemical reaction is our 4th step. The balloon contains baking soda and the flask contains vinegar. When the string attached to the balloon is pulled, baking soda is dropped into the flask. This mixture produces carbon dioxide and inflating balloon. Once the balloon inflates, it activates our next step.
We next have the fluid component. It's the first step, and the water creates pressure from the plunger, which causes the water to move into another plunger through a tube, pushing the plunger outward, hitting a marble. We have a light, which is our last step, which is battery powered, and the light is turned on from a marble falling onto the switch.
We also have our simple machines. We have 2 pulleys, which are used in step 2 and step 8 of our project. We have a wheel and axle at step 4. We have ramps used at step 4 through 6 and steps 11 and 12. And we have a wedge at step 10 and step 13. So first we push a syringe full of red dyed water to represent the blood flowing through the veins. The syringe will push a ball down staggered Jenga blocks glued to a wood panel representing the vertebrae with GPE, where the ball will fall into a cardboard ramp representing a rib. The ball will then fall into a pulley system using GPE, where the cup will fall and the string will pull the balloon to activate our chemical reaction. The chemical reaction will represent the inflation of lungs when breathing and demonstrate elastic potential energy. The balloon will fill with carbon dioxide and it will push a car. The car will slide down the ramp using GPE to hit a marble, and that will fall down the tube. The marble will exit the tube and hit Jenga blocks, which will then hit dominoes. The last domino will hit a marble, which will travel through a ramp and fall into a cup. The cup is attached to a pulley system where the cup is attached to the other end of a popsicle stick and a Jenga block on top. When the pulley is activated, the Jenga block will fall and hit a marble. The marble will travel where it will hit a ping pong ball. The ping pong ball will push 3 popsicle sticks taped together, which will allow another ping pong ball to travel down another ramp. The ping pong ball will hit a set of dominoes, which will send a marble down another ramp. The marble will hit a metal ball, which will fall down a paper towel roll, and hit a switch to turn a light on, representing the heart, which is electrical energy and chemical energy.
Some challenges that we face were with the balloons. With the balloons, we struggled to find the best way to fill them up with baking soda and get it to rise in the same spot constantly. With the cup dropping, as the marble would fall into the cup, it would either stay attached to the side or will not go straight down. Dominoes, we had to make sure they were all lined up to continue our machine. And then coming up with steps at the end, we had to do continuous research and make sure we had the materials to do so. And then keeping the marbles contained, since we were using a lot of marbles, we didn't want any penalty points of it going out of the box.
Did it, Eden?
Is that it?
Yep.
Okay.
The lights on the back.
Good job. Let's hang out. Move along the bleachers down to Saint Ansgar. And then we'll come down the center of the gym. O'Shea is on deck.
Listen to your presentation, watch your team, and then the difference in the final round is what questions that we'll get about your process. But for this one, it's just listening to your presentation. Okay. Morning. Go ahead.
Okay, so our engineering machine is based off of the Hollywood movie Real Steel. If you don't know, the basic premise is boxing and fighting is kind of not a trend anymore, and they now fight with mechanical robots. So we start with the Rock'em Sock'em robot here, classic toy. We hit the head, it will then move this pipe into which a marble will fall into the funnel, activating this car, which will go down this ramp, hit this mouse trap, which will release this hammer, and it will hit the syringes down there, creating our hydraulic step. And it'll hit those dominoes, causing the dominoes to fall into this bouncy ball here, hitting into this cannon, which will hit more dominoes, going up these stairs, which will hit this marble, which will go up the elevator, to which the marble will then fall down that pipe, activate a switch to activate this wheel up here, which will spin around and put that cup into a magnet, put that magnet into a cup, which will then fall into this funnel type thing, activating a pulley system to create our chemical step of baking soda within the balloon falling into vinegar, creating carbon dioxide, lifting the balloon to make some sort of image. And I forgot to say our mechanical step is the mousetrap activating.
We ran into quite a few problems, mainly with the mousetrap. We got really attached to the car that's running into it. We fondly named him Jerry because of how many times we ran through it. Same thing with the elevator, ran into quite a few problems there. The switch wouldn't activate a few times, but we ironed those out. And that's all we had.
We're ready.
All right. We are the Osage physics team. My name is Ian Square. Trying to tell me.
Isaac Weber.
Jack Sparrow. Jason Moore.
And this machine is called the Lizzie Gambler. It involves a multitude of steps to improve efficiency of the concession stand.
Our machine is designed to help us work concession stand for all our busy athletic events. Some customers want a scotcheroo, others want a candy bar, but we really need to get a hot dog to our hungriest customer.
Of our components that we use, our most major are our chemical reactions, that's vinegar, baking soda, our syringe system, which we're very proud of, our wiring, and our arm length, which is designed to emulate the human arm reverse engineered. The challenges we faced, there were a lot. First, to start with our reaction, we struggled because at first we wanted to do elephant toothpaste, you know, a new innovative reaction. And in reality, that's really hard to pull off. Hydrogen peroxide's nasty to work with, so in the end, we worked with vinegar baking soda because it's more controllable. We've had a lot of trouble. This is just a nightmare to aim accurately. I mean, I hit a lot of people with that. Working with food, I gained about 5 pounds, tried to eat our projects. That didn't work out well. A lot more, but those were the most major.
So starting off, we start with our spatula, launching our scotcheroo into the mousetrap. Our mousetrap then pulls the Snicker bar out, the lever releases and lets the car out. Rolls down this ramp into this container of bolts, falls into the popcorn bag. After that, it lands on the scissors, cuts the string, and it goes down into our hydraulic system, syringe system. After that, we have a syringe on this side that pops a balloon. This ramp falls down. We have a weight here pushing syringe with vinegar in it. Push it in. Over here we have a bottle of baking soda in it that inflates this balloon underneath the car and the ramp. It lifts that car up, rolls down into our knife switch right here, which sets a motor off. Down here we have a little spool with string tied to this trap door. That pulls out and the Twix drops on our mouse trap, which pulls the Snicker bar out, and our final step of landing a hot dog in the hot dog bun. That's it.
All right.
Whenever you're ready.
Don't worry. Don't work at all. Oh. Alright, we'll just go to the there you go.
Team Osage starts strong with spatula, finishing with the hot dog. Now we're into Southern Fredericksburg Team 2. Southern Fredericksburg Team 1 is on deck.
Are you gonna mess with us?
Yeah, I got the ball down here just in case.
Morning, guys. We're just going to watch the presentation of the new machine, and then next time around, question. It'll be a little different in the final round. But otherwise, whenever you're ready, we're all right.
We are the BioCook innovators from Sumner Fredericksburg High School. I'm Isabel, and along here with me is Chloe, Ty, Callan, Caden, Davis, and Jackson. For our machine design, we wanted to show the connection between humans and technology. Through our art on the human side, we have lots of unpredictable splatter and colors, which represents the human brain. And then for our robot side, we have simple and predictable art, which represents the brain and robot. Through our steps, we also wanted to show the connection between the two. So we have a prosthetic hand, which shows a connection between the two and how it can benefit our lives.
For our storyline, we start out with marbles falling down our brain, acting as neurons going down the brain. And then for step 2, we have a balloon filling up, acting as lungs. And then step 3, we have marbles and golf balls rolling down the inclined plane, acting as food going down to your stomach, which is step 4. You have your golf balls in your stomach. And then step 5, this hammer hits the syringe, which is releasing toxins inside of your body. On step 6, it shows how many human moods can change fastly. And then step 7, we have that car rolling down the ramp, setting off the bionic leg, which shows a direct connection between human and technology.
Then our bionic leg sets off the string, which sets off the systematic chain reaction coming up the robot here, set off our limit switch to turn on the brain, which turns on our lights, along with our motor, kicking a marble out of the robot. And then we tried fixing the robot with the wrench and putting a gear back into it, which kicks that marble down, puts the golf ball in the cup, setting off the balance of that there and setting the weight off to pull the finger of our prosthetic hand and celebrate with our flags at the end.
The engineering design process is important because it allows students to use their knowledge, skills, and resources to find a solution to a real-world problem. We utilized the EDP in our advanced electrical step. We had to figure out a way to turn on the LEDs in the robot's eyes. Through our background research, we researched what materials would work best, and we had to specify requirements, which was to make it run continuously so we didn't have to keep downloading it to the VexNet brain.
We also used the EDP process here in step 9. We had to figure out what weight of marbles to use to knock the blocks off the other side, and we also had to counteract with friction to figure out like what material to use and like what type of paint will give us the perfect amount of friction.
So we knew that this side was going to end at the bottom, and it would be a good idea to, on our step, to bring it back up so we had more potential energy to come back down. And so we looked at some videos and found these 3 inclined planes. And so that leg kicks it out, pulling the block, and there's marbles sitting on top of the blocks having enough kinetic energy to hit the block at the bottom out and then continuing up. And that pulls out that limit switch starting the electrical step.
And then Caden talked about our electrical step, that's our advanced component. And then Jackson and Callan, their upward chain reaction is our mechanical advanced component. And then over here we have our chemical advanced component where we have acetic acid, which is vinegar, mixing with the sodium bicarbonate of the baking soda. Those, when they mix, they emit CO2 gas, blowing up our balloon, lifting our lever, and starting this half of our reaction. Down here we have our fluid power advanced component step. Here we use Pascal's law, which states that in a closed system, the force in cross-sectional area of this syringe will equal the force in cross-sectional area of that syringe, meaning that because this area is bigger, we will have more force exerted by the littler syringe, which allows us to push our heavy weight down and start our transition between human to robot. And overall as a team, we all came in with very different skill sets, and we had to figure out how to work together to create this, and we found that what worked best for us is we divided into multiple different groups, and different people took different steps. And that allowed us to work on 5 steps at a time, which allowed us to get this all put together quick and then troubleshoot later on. And I would say our biggest takeaways as a team were teamwork, communication, organization, and then determination, because this did not run as we planned right away, but we were determined to get it to work, so we put in a lot of extra hours out of class to get all of the little nitpicky pieces and details to work together.
from Sumner Fredericksburg Team 2, we move down the center aisle to Sumner Fred Team 1.
It's good.
Your presentation, watch the machine run in the final round. One thing that'll be different is we'll be asking some questions about your process.
Is it okay if we do what they did, give our speech and then set a few things on and run it, or do we have to be set up beforehand?
Well, just like what they did.
Yeah, I think that would be fine. Okay. Like if it's different for the finals when we're judging, we'll let you know.
Okay.
All right.
Okay. Human Detect Transfer allows us as the senior scientists, Jesse, Olivia, Colton, Joseph, Claire, Mila, Ava, and Hillary, to get everyday activities easier. Today, not everything is able to be done by humans, so technology helps with just health, sustainability, security, and the overall processes of life.
Our first human starts with gears turning, which relates to our brain and how our brain works. In the second, we have a lever down by the knee, which acts as a joint. And in our third body right here, we use technology, and we have learned that technology comes a long way and changes as fast as a light bulb turning on, which is our end step.
One of the first steps we utilized the EDP process for was for this water wheel we have on the second body. We found it upon researching different steps from different groups that competed in competitions across the world. We have a syringe that gets pushed by this weight, and it pushes the lever on the water wheel so it spins like this. And originally we had water in it, but since we have electrical components, we didn't want to chance the water coming out of the funnel, so we changed it to marbles. In addition to that, we found the marbles would fly out of the funnel because it wasn't tall enough to cup them in, so we had to become innovative and we had to use cardstock paper to keep them in there.
Another way we used the engineering design process was on our third body. The weight would not accurately hit the syringe every time, so we had to research and find out why it was not hitting it every time, and then we had to redesign it so that it would hit the syringe every time. And then the syringe would also hit a lever, and sometimes it would not hit the lever strong enough to hit the next lever to release the car. So we added a weight to the lever so it would gain more momentum and it would have more leverage when hitting the other lever to release the car.
So once we're set up, this weight will be down here, and once it falls, the pulleys give it more kinetic energy, allowing the humans to split apart. And then this weight falls into there, running that body, and then once everything runs down here, that cart comes to this limit switch and tells the brain to turn the motors on, which spool, pull the second person apart. Once the wheels hit this limit switch, it tells the brain to tell the motor to shut off, then tells the servo to turn, drop in the trap door, and then running that body.
The easiest advanced component for us to come up with was our chemical reaction with sodium bicarbonate and acetic acid, and we placed it in the stomach to resemble the chemical reactions that happen in your stomach. And our second one is the fluid power, which relates to your heart with the oxygen moving through the heart, and the same amount of pressure from the first syringe goes into the second syringe since it's a closed system.
Our electrical components can be found in our light switches. Our light switch starts our first body by turning on the gears, and our second light switch ends our last body by turning on the light bulb. Our light switches are series circuits, which means they're a closed path for electrical current to flow through. And our mechanical component, we have 4 simple machines: levers, pulleys, wheel and axles, and inclined planes. One of our most major mechanical components is our pulleys. They are fixed pulleys, which means the wheel is stationary in one spot and the string moves along the groove. And their mechanical advantage is 1 because the input force is not increased.
Our biggest challenge was being vocal. We did not want to come up with any ideas that could be detrimental to our team, and we also did not want to step on each other's toes. But once we started building off each other's ideas, we were able to make progress and be efficient. In step 12 and 13, we had a big challenge there, and we were able to solve those problems by being cooperative and building off of each other's ideas.
I want to set it up real quick.
A good run by Sumner Fred, Team 1. Now come down the other side by the bleachers. We'll start with the junior team from Mount Air, and we'll finish up this round with Saint Ansgar.
So we're going to let you do your presentation and run through this once and use loud voices to help me, who's hard of hearing. And later on, we'll ask you questions in the second time through. So have fun.
My name is Kensington McAlexander, and I am a member of the Mount Air School 6th grade tag group, which also includes Nash Health, Easton Weber, Kaylin Schaefer, and Kinsley Newton. This is our machine to make that.
My name is Nash Rupp, and our theme is the human body, and we are telling the story about what happened to Timmy one day. Timmy was walking down a path there, and then he stubbed his toe on a bench there, and then that set a pain receptor nerve off in his toe there, and then the pain traveled up the nerve to the spinal cord. Here. The spinal cord sent the nerve up to Timmy's brainstem. Like when it falls onto that, the brainstem transmitted the pain sensor to Timmy's brain, which is the balloon blowing up, knocking the tennis ball off. The brainstem transmitted the pain sensor to Timmy's brain. Timmy's brain received the pain sensor information and processed it, which is the ball falling. Timmy yells ouch where the book falls, or where the tennis ball hits the books and falls. And then Timmy grabs his toe to calm the pain sensors, or when the red ball swings and hits that. And then Timmy does not feel the pain anymore when the bell rings.
My name is Easton Weber, and I am going to tell you about the ways we use the engineering design process. At first, we had a ramp for the beginning. We fixed the ramp a lot, then we decided to get rid of it. We got rid of it because our ball wouldn't roll down the ramp, even after we made modifications to it. We made changes to our design by making the ramp smaller with sides so that the ball would go down and have better guidance. We made our base too big so it would not fit in the Suburban to haul, so we had to make the base a little smaller. We made it smaller by cutting 4 inches off of the base so it fit in the SUV. We also determined that the best place to cut the excess from was the bottom of the base. Then we would just flip the base on its side to slide into the Suburban. We wanted to have a book push a syringe for a chemical reaction, but the book would fall off the cardboard platform. So we made sides on the platform to hold the book into place, and now it works. We wanted the balloon to blow up and knock over the tennis ball, but the balloon was too small. We ended up making the balloon bigger by sizing it up to 12-inch balloon instead of a 9-inch, so that way it would knock the tennis ball off. My name is Kinsley Newton. I will be telling you about the integrated STEM process. We decided to put a chemical reaction into our machine. When we did this, we had to combine mathematical knowledge to determine how much ingredients to use, scientific knowledge to determine what things would react to make gas to blow up the balloon, and engineering design to put parts together to make a reaction happen.
My name is Kaylin Schaefer, and I will be explaining the machine steps. The first step is the metal ball going down the inclined plane. The second step is the metal ball going into the bucket. The energy of the ball moves the pulley and the other bucket goes up to the marble run. The third step is the marbles reach the top of the barrier and then go out of the bucket and down the marble run. The fourth step is when the marbles hit the book, causing the energy to transfer and fall on top of the filled syringe. The fifth step is a vinegar-filled syringe releases vinegar through a tube connected to a bottle, and the bottle has baking soda in it. The sixth step is that the baking soda and vinegar causes a chemical reaction that builds up carbon dioxide gas and blows the balloon up, which knocks the tennis ball over the tall platform. The seventh step is when a tennis ball falls and knocks over the books. The eighth step is the books falling and pushing the rubber ball into the books. The ninth step is when a rubber ball hits the dominoes and it causes them to fall over. The 10th and final step is when the dominoes fall on top of the bell and ring the bell.
The biggest challenge we faced was time. Our school had a lot of school canceled because of snow, so we got behind schedule and had to arrange extra time for our tag group to finish our project. During the last 2 weeks, we had to talk about prioritizing what was most important, and we decided that we just wanted the machine to be finished and a machine to bring to the competition. We did not care if we had to touch it some to make the reactions work. We had to sacrifice perfection to just get them done, and that was kind of like the Wright brothers we learned about last year. The first flight was only 12 seconds, and the plane was far from perfect, but it made history and did what they wanted it to do. We are like the Wright brothers. We will keep making improvements to our machine over time if we qualify for nationals.
Getting there.
There's not enough vinegar.
Great job by the junior team from Mount Air. Now we'll finish up the prelims in the senior division with Saint Ansgar.
Listen to your presentation and watch the machine, and then when we come back for the finals, if I have some questions, that'd be
My name is Max Beeland.
I'm Hannah Clevenger.
I'm Aspen Fall. I'm Kayla Hickman. I'm Kinsey Anderson. I'm Martin King.
I'm Alex Lentz.
I'm Drew Powers. I'm Carson Sparrow, and we are
the Medical Mob.
Our project starts with the systems that supply us with what we need. So in our body, these are our veins, and in our communities, these are our piping systems. So the water will flow through the PVC into the next step while the veins fill with blood. I have the second step, and this step is the mouth, which it causes the saliva from the previous step causes the cup to tip over as it pours into the cup, which falls onto the cotton candy. And in advancements in technology, we could make food packaging dissolvable, so it's more sustainable.
Once the saliva pours into this, it falls onto the cotton candy, which dissolves the cotton candy, and the cotton candy breaks down into smaller pieces of food, which travel through the digestive system and fall into here, which is nutrients being absorbed, giving us energy to open and eat. And through our digestive waste, we produce methane gas, so we could use this as an advancement to technology to bring methane into our everyday homes.
I have the next steps, and they're based on the knee. I chose to do this because I've had 2 knee surgeries in high school, so I thought it would be fitting. So my step starts, as Kinsey said, after the teeter-totter opens and that ball sets off a mouse trap.
The mousetrap then pulls that pin and knocks a ball down a ramp, which hits a door. And the door and the knee are related because they both use a hinge movement, and that can be used to advance like braces that are made for athletes after they're injured.
And then my step starts after the door knocks over the bottle. This is also our chemical step. In the balloon, there's baking soda, which combines with the vinegar in the bottom of the bottle. This tips over, the balloon fills up, and it knocks off that weight. This represents the lungs in the human body and how it could be used to advance technology. You can use an artificial lung to help like a smoker or someone who has lung problems. After that weight's knocked off, it pulls out a pin that's holding up the bowling ball. This is also our fluid power step. There's a little launch pad at the bottom. The bowling pad launches on it, and then that sends the rocket back up to the top of the machine.
Add the electrical step, and the ball rolls down and hits this guy, releases him down, hits the switch, turns on the motor, pulls the scissors, and releases the next step. This tube represents like a copper pipe, and the guy represents work we do every day. And the 3D prints, which I designed using CAD software, are like magnets, and copper and magnets are combined, they generate electricity, which is then used by us every day, which is what the electrical step is.
The yellow pendulum is a ray of light that when it hits the cornea of the eye, we can see the world around us. So once the eyeballs hit, it hits that lever which turns on the laser, and using law of reflection will reflect off the mirror, popping the balloon. And to advance technology, we could use lasers to see whole images instead of using screens.
When the balloon pops in Aspen steps, it's holding marbles, which are representing air molecules, which go down through the vocal cords and hit the tuning forks. The tuning forks create longitudinal waves, which vibrate the air around them, creating the noise you hear. With all the noise going on in big cities, not being able to talk keeps you one step behind. To get you that step in advancement, we have thought of is to find a way to make technology that can read your brain waves so that people that can't speak to others can communicate through their thoughts.
For the mechanical step, after the marbles fall through the chime box, it goes in this cup, pulling the cup down, lifting this iPhone stylus up. It does this by it's attached to a string, and pulleys allow assisted pull up. Is then pressing the play button on my iPhone. It won't actually play until it lifts up. So in the future, we could help hearing impaired individuals by converting longitudinal waves into electromagnetic waves, and it'll be attached to their ear like a Bluetooth device, allowing them to hear correctly.
My step is the brain. It starts on over here when the cup falls onto a battery, which pushes the battery into a switch, which turns the lights on. This lights up the brain and the light bulb. A brain lights up with ideas like a light bulb, and all of these steps represent how advancement can help the human body. Okay, you're ready to go. Okay.
Good run by Saint Ansgar to finish off the preliminary round. Now there'll be a very brief intermission as the judges convene. Then we'll come back in and run the finals right away. For the finals, I will hand off the microphone to each team to give their presentation, and the judges will ask questions. Go ahead and get reset.
As long as you just keep talking.
this one. Oh no, recycled. I don't care about that. Yeah, I wonder who wins junior. Only one junior does that. Then we have people choice. Super smart.
I think you're walking at it. Hey, Max, hold on. Spirit, we're gonna interview you. You're gonna go on the wall so that this is a boom mic.
It's a what?
It's a boom mic, so that means like, yeah, it picks up like things behind you too. But we don't really know how this is supposed to go, so we're asking this person first. Alrighty.
Should I do this?
No, I feel like we need to get back up that way. Alright, there you go. That's good.
Do I need to talk louder?
No, it should pick it up, I think. Hey, Weston. Weston. No, I went to start. So, how do you think your Rube Goldberg went today?
I mean, that was a practice run, so didn't really count for anything, but it did work all the way. I am happy about that.
You feel pretty good about going into the qualifying round?
Yeah, I feel pretty good about it.
How do you feel about the other contestants?
There's some pretty cool projects here. Some really cool steps that we didn't think about. And they thought about stuff a lot differently than we did, so that's pretty cool.
Do you think you have the upper edge?
The upper, like, do you think that
we
won that practice round?
Yeah, a good chance of winning.
To win?
Yeah.
I think we got a good chance to win.
Right.
We just gotta make sure that our project doesn't fail. Because every time we touch it, it subtracts points, and just gotta rely on what we do best.
Thanks, dude.
Hey. Thank you, sir.
Should we get in the room? Oh, yeah. They would be so nervous. No, we needed to do.
Should I get Jack Sparrow?
Yeah, go get Jack Sparrow.
They split them.
Jay, you come with me? I'm not gonna do it.
Dude,
you got to. I already did one. I already did one. We need you to do an interview for it. Is it live right now? Live. It's on you.
No, I just
on there.
Jack,
you're embarrassing.
You are a sparrow.
I am.
Expect greatness.
Just checking out the projects.
Mr. Johnson, comes to 6 I'm gonna make it wait,
I'll film these spots. That's not the wrong side.
Who's got three?
My hand is the
Does anyone know what markers are? They should be in there. Unless they're like.
It's supposed to be more. Soft.
For teachers, and I emailed them and I said,
Wait, what happened? 1 o'clock.
I don't want to be in the picture.
You want to get it?
My mom's not streaming it, but still.
Just a reminder, we reset for the finals. If you have not turned in your team ballots, please do so now. Thank you.
Where do I go turn it in?
I would assume that's
Can you go turn it in? Or?
You can. You have. Did you fill it out? Oh, okay. Keep it lively.
No, we're leaving it like that
And the right before the wrong right
Not a lot of work there. Not a lot, but enough. Oh, there.
I thought you were after the whole minute.
You interview anyone else?
No.
You should interview Summer Fred.
I know, I'm going to.
You were saying after
It's not that hard. My mic's not in yet, so I just asked you like how you think it's going and stuff.
Just
kind of, you can say kind of what you said over here for the start. You can just stand on the wall over there.
In this round, I'll pass out the microphone. You'll give your presentation. You'll start your machine. Then the judges will stay.
You don't get an interview with them?
Here with Rockford.
That boy's like Snoop Dogg.
How do you guys feel about the Rube today?
It's going good. It's been working good our first run here, so it keeps up in the final.
How long did it take you guys to set everything up?
This morning, got here at 7:30. It took us about an hour to set it up, and then we ran it a couple times after that.
How long did it take to like build everything then?
We started prepping stuff before our Christmas break, and then after Christmas break we came back and been working on it the whole month of January up until last Friday, making final tweaks and stuff.
Are you guys all seniors then?
Our group is all seniors. That's why we're the senior scientists. The other group has some juniors mixed in.
Okay. And you're all in physics, I assume?
Yep, we're all in physics.
That's good. How do you guys feel about going into the prelims there?
Okay, we are going to start our final round.
I mean, kind of everybody
We'll
makes
start
it. So
down
we
here
really
by
don't know
the
how we're doing
stage
so
with
far.
Rockford, and I will
2017,
hand the
everybody made it to the
microphone.
finals, but yeah.
All right.
Hopefully we do good.
Thank you.
Thank you.
My name's Corbin. We're the Rocks, and this is Maggie.
The purpose of our machine is to warn people before a chemical reaction happens to catch the reaction.
All of our steps were used from repurposed materials from past experiments. And our first step is the hydraulics. Push this golf ball down this tube. It comes back here, hits the board to slow it down to keep it from falling off, falls into the bowl. It weighs it down just enough to keep that metal ball from rolling, and it hits this platform. It goes down, follows this track into the bucket, which once it goes to the bucket, it pulls the string, pulling the dowel into the ramp, allowing the weight to hit the truck, hitting the bell, the electric switch, hitting the weight, causing our chemical reaction. And then it is our last step is the chemical reaction, and the bucket is to catch all the overflow from it. We struggled designing this too because the golf ball kept falling off, and we had a hard time finding the right weight to pull the plunger out.
To fix all those issues, we added this little, whatever you call that, thing. And then we had a lot of issues with it just bouncing off, so we had to add dowels under the track.
What part of the design are you guys most worried about, or what part is always your hardest to get to go through or work?
What's the hardest is probably everything. It likes to bounce sometimes. Oh yeah, and then the pin, this doesn't like to pull out, so that, hopefully that works. Alright.
So you'll have 4 minutes to reset, and then we'll watch you run again.
What's going on?
So we'll stay right here with the judges as Rockford resets for their second run of the finals.
And then we can ask questions after that presentation.
It's alright, it's good. We just want a bit of a faster reaction, so how would we change this to a bit faster?
here. Actually, I'll take the plunger out. Actually, no, we don't want these. Here, just lift the whole thing up. How'd you get it on you? Oh. Yeah, the tree farm over by this guy.
I think so. Yeah.
Not Osage, Colorado.
Yeah.
They always have apple cider.
Except for Rick.
Everything could come out that average.
His mohawk makes the camera sit up more. Don't hit the camera. Go sit over there. You can see it better. Can you? Okay. Alright, you can sit. Alright.
You guys are good?
Yep.
All right.
Did you guys make any changes?
No.
Nope.
Hey, good job with your research.
Thank you. Yeah.
Are you guys ready? You ready?
Whenever you are.
Judges? All right.
Nice job, Rockford. That wraps up their final 10. I'll move down the line to West Hancock for their first finals presentation, and St. Edmund will be on deck.
Hi, we're from Saint Ansgar High School, and I'm Eden, Caitlin, Emilio, Mallory, Whitney, Sydney, and Evan, and our project is called The Take Job.
The story of our revolver machine is that it represents the human body. The red will live in place it belongs to, the red liquid flows through the surges like blood through the veins, and the heart is represented at the end by the light that is turned on. The wooden box represents the vertebrae, and the ribs are represented in a cardboard tube carrying the marble.
Our team used the engineering design process from working at the end forward. We knew our last step would be turning on a light bulb, so we worked from there. The 4 advanced components were key, and we searched on TikTok and YouTube. Our ideas that we found were based on trial and error, and we made small revisions as needed. Our first advanced component is our chemical reaction. Chemical reaction is our 4th step. The balloon contains baking soda and the flask contains vinegar. When the string attached to the balloon is pulled, baking soda is dropped into the flask. The mixture produces carbon dioxide, inflating the balloon. Once the balloon inflates, it activates our next step.
Our fluid component is our first step. The water creates pressure, which pushes the plunger, causing the water to move into another syringe, which pushes the plunger outward and outward. Moving on our light is the last step. It is a battery-powered light that is turned on when the level flat into a switch.
And lastly, we have our simple machines. We
We have 2 pulleys that are used in step 2 and step 8 of our project. We have a wheel and axle, which is at step 4. We have ramps used in step 4 through 6 and 11, and steps 11 and 12. And we have wedges at steps 10 and 13.
Now going through our machine steps, gravitational potential energy will be referred as GPE. First, we push a syringe full of red egg water to represent blood flowing through the veins. The syringe will push a ball down staggered Jenga blocks glued to a wood panel representing the vertebrae with GPE, where the ball will fall into a cardboard ramp representing a rib. The ball will then fall into a pulley system using GPE, where the cup will fall and the string will pull the balloon to activate a chemical reaction. The chemical reaction will represent the inflation of lungs when breathing and demonstrate elastic potential energy. The balloon will fill up with carbon dioxide and it will then push a car. The car will slide on the ramp using GPE to hit a marble and that will fall down the tube. The marble will exit the tube and hit the Jenga blocks, which will then hit dominoes. The last domino will hit a marble, which will travel through a branch and fall into a cup. The cup is attached to a pulley system where a cup is attached to the other end with a popsicle stick and a Jenga block on top. When the pulley is activated, the Jenga block will fall and hit a marble. The marble will travel where it hits a ping pong ball, and the ping pong ball will push 3 popsicle sticks taped together, which will allow another ping pong ball to travel down another ramp. The ping pong ball will hit a set of dominoes, which will send a marble down another ramp, where the marble will hit a metal ball and it will fall down a paper towel roll. The marble will hit a switch, turning a light on, representing the heart, which is electrical energy and chemical energy.
Some challenges that we face are the balloons. With the balloons, we struggle to find the best way to fill them up and for it to rise up in the same spot. For the cup dropping, as the marble would fall into the cup, it would either stay attached inside of the box because the tape was too sticky or not go straight down. Dominoes, we need to make sure they're all lined up to continue our machine. And coming up with steps at the end, we had to do continuous research about new steps to make sure we had the materials to do so. And then for keeping marbles contained, we have a lot of marbles in our project, so we're giving it to go out of the blue square to darkest points.
What's your guys' favorite part of the, or most proud part of the whole machine?
If we can get this, this whole on top of the box thing to work, there's a lot of kind of tricky balancing.
That took us the longest to come up with, and then once we got it, we were happy that it started working consistently.
Was it hard to move it from where you had it before and get it reset just like you had it?
Yeah, a little bit, just because we knew exactly in the classroom where we had it, and then coming here we kind of had to adjust and envision if it was in our classroom how we had it.
What process do you use to get that to work? Trial and error or different things?
Yeah, yep. So we did some research because this was kind of our last steps that we had to come up with, and so we kind of just worked like little bits and looked at videos and then just kind of trial and error.
Any other questions? All right.
Oh, yeah.
Well, I think this is a reissue, but theirs was brand, so they're okay.
You guys make any changes or adjustments to try to make it perform differently?
I adjusted my Jenga box a little bit. Yeah, and then we noticed our light switch was kind of tilted, so we adjusted that and put it back in place.
You still have a little bit of time if you had anything else.
Like, do you want to try the color? See if it falls and touch it? Just touch the cup if it falls. Don't overload things.
So when you're ready, and
We move on to Saint Edmund, and Osage is on there.
Good morning. We are the team from St. Ansgar School. My name is Zach. This is Denny, Ashton, Dominic, Aiden, Levi, Sawyer, Miguel, Max, and Cooper. I am going to tell you about our theme. Our theme is based off of the movie Real Steel starring Hugh Jackman. And to figure this out, we were just thinking, and then someone was just like, hey, what about like Real Steel? And most of us were like, what is that? So we watched the movie in class, and after a lot of ideas, we decided to go on an approach that robots are fighting. And we noticed Hugh Jackman's robot got destroyed a lot. So basically what happens is it starts with a fight. The blue rocket soccer robot represents Hugh Jackman's robot named Adam. And he is about to get his head ripped off. So the red guy will punch him, and then basically everything afterwards is like electrical components within Adam's brain, like frying, freezing, and all that, until eventually at the end, when the balloon comes up, it represents his head coming out.
So more specifically on the steps. First step, we got the rocket sock. So after Adam gets right uppercutted, we got a small over right here. Head comes up, piece, he's going to tilt it down. So that marble is going to travel. And then it will land on the funnel, which the funnel is going to move as far as we gave the very. It's going to move down here, and it's going to hit a nostril. And instead of nostril, we have a string, which is connected to a dowel that we cut it up. So that's going to be released, and then the hammer is going to fall, and then hit a hydraulic. And that hydraulic with air is going to push each smaller hydraulic, and then dominoes are going to move up the stairs, and then it's going to hit a marble, which will go down, and with use of the electricity, that marble is going to shoot to that plastic bag, and more dominoes will go, those stairs, and then with a domino that's glued to a popsicle stick, it's going to hit a ball. It will go down and it will hit the floor or a switch, which the elevator will go up, and then the marble is going to go down to that height, hit another switch, which will activate this right here. So it's going to spin clockwards. It will connect with the magnet. The magnet's going to land on this contraption. It will go down this cup, which will move down as the balloon will go up, and with the use of vinegar, baking soda, the balloon will expand to grand shape.
We ran into 4 major problems with 4 of our steps. One was the mousetrap. We had a lot of problems with consistency and didn't want to pull out the hammer to let the hammer fall. Another one was our bouncy ball cannon. The internals kept turning itself apart, and it was really bad one to fix. Another one was the elevator. Another lot of problems with consistency. We had to deal with friction a lot there, and we couldn't get the elevator to go up, but we fixed it. Same with the wheel, we had to deal with a lot of friction and eliminating that there.
Are you guys a pretty big group? How'd you guys coordinate? Everybody being able to work on it together, or
At the start, we weren't very coordinated. We split up in too many small little groups that weren't very coordinated very well. But then we kind of gathered up into larger groups and coordinated on different walls and the floor, and we just connected everything after.
what part of the project did you guys find the most fun?
I would probably say the Rock'em Sock'em part. We took that thing out and then we kind of messed around with it for a little bit. But yeah.
Like, where's that?
City and Edmond will now have 4 minutes to reset for the second round of the finals. Osage will be up next.
Did you? Yeah.
All right, good job, guys.
Good work. That wraps up St. Edmunds and Debs. Next, we'll come to the middle of the gym for Osage, and the Summer Fredericksburg team will be up next.
Ready? All right.
So, hi, we are the Osage physics team. My name is Ian, this is Connor, and that's Isaac, and that's Jack, and then at the far end is Kristen. So this incredible machine you're looking at is the ability handler. It involves a multitude of steps to improve efficiency of the concession stands, and obviously it looks really cool.
Our machine is designed to help us work the concession stand at all our busy athletic events. Some customers want a scotcheroo, others want a candy bar, but we really need to get a hot dog to our hungriest customers.
Major steps in our convention here include our vinegar baking soda reaction for chemical. That wiring there is electric. Pretty much everything else is physical, and our hydraulic is the syringe pumps. During the making of this machine, we faced a couple of major challenges, namely the reaction. We wanted to do elephant toothpaste, and that is, as it turns out, very difficult to control. So we switched last minute to vinegar baking soda, and we've also had some trouble with the wood warping, just old wood, you know, and just working with everything. But we cooperated, innovated, and got together, and we did the best we could with our circumstances.
It starts off with a scotcheroo bar launching onto a mouse trap, and then it takes out this bar here and raises the car, which hits our weight, and then cuts the string on the car that rolls down and hits the syringe, and then that pops the balloon, which lets the weight push in the vinegar, and then that starts our reaction that lifts the car, and then the car hits the knife switch, and then up front here, that spins the motor, it releases the bar off the trap door, and then that lands on the mouse trap and releases the hot dog into the bun.
What part of this is kind of your biggest what if, or will it work or not, or what's your hardest part to get to work every time?
Probably the chemical part. We started with one thing and then we just kept on going down to the next until we got something that works. But just finding something that's not too heavy or too light to go down on that knife switch to set the motor off, and just finding something for that was pretty difficult.
What part of the project did you guys find most fun?
Yeah, it's definitely the beginning where we have to launch the Scotcheroo. Because a lot of time, even if we weren't trying to like set it up, we could just launch it for fun.
All right, I think we're set.
Trial and error, folks.
Fire. I think our mousetrap is set.
Your mousetrap's not set?
So
So
maybe.
should be. I think your route is.
Yeah, right. Fire.
Get close.
Go. Osage will now have 4 minutes to reset and do their second run of the finals. Both teams from Summer Fredericksburg will be up next.
We'll let you know in like 2 minutes.
That's gonna miss.
There's a balloon.
It's not set yet.
Randy Jackson, does he play? This doesn't anyway. Ready?
We gotta set it closer to the
Guess what happened was there was already vinegar shooting into the baking soda thing.
Run into that cage.
I don't know where you want this.
Oh.
It is great that people if anything, Tristan, get the balloon under there. No, get the balloon. No, it's inflated.
Wait 10 seconds.
Is it deflated? Is it expired? Get the car there. Wait, switch it. How far does it switch down? Just very. There you go.
Okay, we're done.
Did you guys make any adjustments or changes? Lay anything out different?
On that car, at the beginning of there's a little hangover that we got, or like a garage type thing. We just lifted the front end of that up, so it would release. Slope.
Make sure our mouse trap is
That too.
Yep. Yeah, okay. Why is it too full? Why is it up like that?
Probably can just drop that.
Hey.
Just let it go. Just hit it.
Figure out why.
Too much pressure on.
Oh, this is.
All right, go ahead. All right, that wraps up Ocean's attempts. Now we'll move on to the Sumner Fredericksburg team. Up first, Sumner Fred, Team 2.
I like that you were saying that. I really do. Oh, no, I don't like that. You guys can come to Fred too, right?
Yeah, okay, so text us.
Everyone ready? All right, we're ready.
We're the Biofood Innovators from Saint Fredericksburg. I'm Isabel, and along here with me is Chloe, Todd, Helen, Davis, Katie, and Jackson. Through our machine design, we wanted to show the connection between human and technology. And with our color and our art, you
Riptide is very colorful. It has operating tools that are like the brain-making function. And for the robot side, the art is very simple and predictable, which is how the brain works in the robot. For our steps, we also show the connection between the two. And with our prosthetic hand, it shows how technology can help better the lives of humans.
For our storyline, we start up with marbles falling down the brain and down the spine, acting as neurons. In our step 2, we have a balloon filling up, acting as lungs breathing. Step 3, we have marbles rolling down and golf balls rolling down, acting as food going down in the stomach. Step 4 is our cup. We have our food in our stomach. And then step 5, we have the syringes being pushed out, acting as the toxins leaving your body. For step 6, it shows how many news humans have and how they can change quickly. Step 7 is our car bumping our bionic leg, which shows the direct connection between human and technology.
Step 8 is the car hitting the paddle down there, kicking the bionic leg, which triggers the systematic chain reaction coming up the robot here for step 10. It triggers the limit switch, which tells the brain to turn on the lights along with our motor kicking the marble out of the robot, which falls into our basket here to fix the robot with our wrench and our gear coming back in, kicking the marble off, hitting the golf ball to set off the balance of that there, to kick the weight off and pull the finger to celebrate with our flags at the end.
The engineering design process is important because it allows students to use their knowledge, skills, and resources to find a solution to a real problem. We utilized the EDP in our advanced electrical step. We had to figure out a way to turn on the LEDs in the robot eyes. We researched what materials would work best, and we had to make sure it could run continuously so we wouldn't have to keep re-downloading it to the brain. Once it ran successfully, we can now communicate to the group that the next step can now be done.
We also used an engineering design process here in step 9. We had to figure out what marbles would work the best with different weights of marbles. And we also had to figure out different amounts of paint to use, like different amounts of layers, to give us the right amount of friction, not hold blocks there, but they won't just fall out before the marble runs into them.
So we knew that this side was going to end at the bottom, and on our left side here, we wanted to bring it back up so we had more potential energy. So we looked up some videos on how we could bring it back up because we didn't really know how that was possible. And we found these inclined planes. You can really have as many as you want with these blocks on here. And there's marbles sitting at the top blocks, and they have enough kinetic energy to hit the blocks at the bottom, pulling off the top block, which it keeps going up. And then that ends with the limit switch being pulled going to the electrical step.
And what Jackson and Cal just talked about is our mechanical advanced component, and then over here we have our chemical advanced component, which is when acetic acid and vinegar mixed with the sodium bicarbonate of the baking soda. This causes the balloon to, this emits CO2, causing the balloon to blow up, pushing our lever up, and starting our reaction down the body. Then down here we also have our fluid power advanced component step. In this we use Pascal's law, which states that when in a closed system, the force times the area of this syringe will equal the force times the area of our second syringe. And due to us using a bigger area and bigger syringe here, we're able to have more force come out of the smaller syringe, pushing our heavy weighted marble. And then over the course of the month we worked on this, we all came in with very different skill sets, and it took us a while to figure out how we all work together and what worked effectively. Then we divided our room into different sections, and maybe 1 or 2 people took a section, and that allowed us to work on 4 to 5 steps at a time, allowing us to get this completed and all on the board, and then be able to perfect it from there. And then I would say our biggest takeaways were teamwork, communication, determination, and organization.
Did you guys struggle to get your components that were individual to work well together after you brought it all together, or did everything kind of go to plan for how that was going to be? Or?
I'd say it was kind of hard to know where their step was going to end exactly and how it was going to start. It kind of, I mean, we worked on steps individually, but it kind of all started here, and then we could really finish like 1 through all the way through. So.
What part of the project did you guys have the most fun?
I think seeing it all come together after working on it individualized and then it actually getting together, and then our first run where we maybe only had 2 touches and then, you know, kept finding problems, but then really our first completed run I think was the most fun we all had. These guys were jumping and screaming at our syringes and our balloon to blow up and push our marble, and it was one of our PD days, so all of our teachers came in and asked what was going on because they were screaming and so excited that it finally worked.
So what part of it is your favorite part to have work out?
My favorite part is the electrical step because I got to relearn how to code. I took a class last year where I learned how to do it, but I lost some of it, but once I learned it again, it was really fun to do.
What aspect of your machine do you think best demonstrates the resourcefulness or using recycled materials?
I'd say probably the wood. All the wood was, I mean, it's really what a lot of everything is made out of, and we already had it there, so we didn't really have to get anything new. So.
And I think also the hand that Maya, who's our team member that is not here currently, built is she took all these scrap wood pieces, cut them, used pins and dowels that she had, and was able to create a hand that's pulled by one string and creates curling up of fingers.
I figured that out.
Team 2 will now have 4 minutes to reset. Sumner Fredericksburg Team 1 is on deck. And then we'll go to the other side of the gym for our junior team. Now,
Luke, look at the camera. Look at the camera. Look at the camera, Luke. Look at the camera. Hudson. You get it. You're on top. No, I'm not.
Yeah, which makes total sense. I just I don't know what it is.
There was a lot more vinegar.
I don't know what. I just wouldn't want. I have the. So,
Is that just
one of ours. That's what I
so this wasn't in the right spot in the balloon very good, so it didn't allow it to move.
I was glad that this was.
And this one I'll really just see, I gotta wait to see if that's just off. See how it's moving at all? Is it hard?
You know, I was thinking about that. I was talking about engineering as a safety factor before you start something. We're gonna. I'm good with setting up.
Right.
I was just thinking, I would want it different. Not sure the friend. That's how I would. About a minute and 30 left.
Can you flip this on? You can flip it on, yeah.
What did you decide? No. As one is allowed.
A marble one too?
Or I'll just make the call. Yeah.
You can do that.
Still have a minute, so.
Did you guys change where anything was or make any modifications?
Well, on this chemical stuff, our balloon, a little bit of vinegar on the other one kind of went in, so it blew up just a slight amount, so that we could only, our strings could reach on the lower point, so it didn't allow all our vinegar to get up and go into the balloon.
Sure. There's one on the tripod.
The paint just, it sticks sometimes. The paint does to each other, so you gotta kind of rub it around.
Sure.
So.
Okay.
You ready? We're ready. Yep.
Hit it?
Not bad. I kind of like
Hit
it.
it?
Yeah.
Hit it? It's fine.
Next up, we'll have Summer Fredericksburg Team 1. They'll do their presentation and be asked a few questions. Next will be our junior team from Mount Air.
Human Detect Transfer allows us as a senior scientist, Jesse, Olivia, Colton, Joseph, Claire, Nyla, Ava, and Hillary, to make everyday activities easier. Today, not everything can be done by just humans, so technology helps with sustainability, health, security, and overall processes of life.
In our first human here, we have the gears, and they act as how our brain talks. And then in the second one, we have a joint and the lever, and we started bridging the gap between the human and technology by thinking of a joint, because in knee replacements, they have artificial joints. And then in this final robot, we bridge the gap in between human and technology. Technology has come a very long way, and the light bulb turns on as our end step as technology. We utilize the EDP process, or the engineering design process, most often on this step we have here, the water wheel, on our second body. So we found this upon researching different routes that competed across the world, and we thought, oh, we would like to use this. How can we make it work for us? Initially, we had water within the cups, which we were going to pour into our funnel here, but since we have open wires and electricity here, we didn't want water spilling, because you don't want water and electricity. So we thought, oh, what can we replace the water with? And we thought marbles would work, because we need marbles to go down into the cup to start a lever. Initially, it worked fine, but the marbles were falling out of the funnel, so we had to become innovative, and we had to think of a way to keep the marbles within the funnel, so we used cardstock to create a little boundary.
In our third body, we also had to use the engineering design process to solve the weight hitting a syringe. The weight would not accurately hit the syringe every time and push it all the way down, so we moved the syringe closer and got a different shaped weight so it would hit the syringe more accurately. That syringe would also hit a lever, but the lever would not have enough momentum to push another lever to disengage it with tape from a popsicle stick. So we washed it and found what was wrong with it, and then took off extra parts of the wood because it was hitting too close to the fulcrum, so that way we could have more leverage on the other lever.
So when we get started here, this mass goes here. When it falls, the pulleys give the mass more kinetic energy, allowing the first people to split apart. Then that weight right there is pulled, dropping, running that body. This body splits in half. Well, first this car gets the limit switch telling the brain to turn the motors on, which spool the string around and pulls the bodies apart. Then the wheels hit the limit switch down here, telling the brain to shut the motors off and tells the brain to tell the servo to turn on, dropping the trap door, allowing the mass to fall down in the cup, and runs that body.
The easiest advanced component for our group to come up with was our chemical reaction, which we placed in the stomach, which represents the chemical reactions that happen in your stomach. We use sodium bicarbonate and acidic acid, which when they combine together, they produce the carbon dioxide, which expands our balloon and knocks the mass off, which makes the people split. Another advanced component is our fluid power, and in our fluid power, the fluid is air, which we use to represent oxygen in your blood as it goes through the body. And when the weight falls and hits the syringe, the same amount of pressure in the first syringe transfers to the second syringe to close the syringe system.
Our electrical components, a good example of that is our light switches. On our first body, it turns on our gears, which starts our first body, and it ends our last body by turning on a light bulb. They are a series circuit, which means they are a closed circuit for electrical current to flow through. And our mechanical components, we use 4 simple machines: pulleys, wheels and axles, levers, and inclined planes. A good example of our mechanical component is our pulleys. They're fixed pulleys, which means they are fixed to one spot, they don't move, but the string goes through the groove. They have a mechanical advantage of 1, which means the input does not increase, it just changes directions.
Our biggest challenge is being vocal. We do not want to present any ideas to the team that would be detrimental, and we do not want to step on each other's toes. And we overcame this just by building off of each other's ideas. Another big challenge was making sure that mass falls in the syringe, and making sure that this weight is heavy enough to split the bodies. And our biggest takeaway is that you need to work together to achieve anything.
Did you guys have to do any modifications on your wheels or anything to make it roll a little bit better? It looks like
yeah, so right away, they have a little slot down here in the wheels, and I had to like adjust them to where the bodies weren't tipped. So to try and get the bodies level, like the one, say the back wheel, say the body was leaning this way, I had to adjust the back wheel to be down lower and bring this one up so it would level itself out. Otherwise they were tipping over and falling down. It was knocking everything over and it was bad.
What's your guys' favorite part of the machine?
My favorite part would be the brain and the electrical system, and how we have a limit switch on the body that then tells the brain to turn the motors, and then hits another limit switch, which just creates a series within the brain. And it's amazing that technology can be programmed to operate with what we want it to do.
Our biggest challenge is being vocal. We do not want to present any ideas to the team that would be detrimental, and we do not want to step on each other's toes. Another big challenge was making sure that this weight is heavy enough to split the bodies. And My favorite step is when this weight falls and splits the two bodies apart and pulls that way down.
My favorite step is when we have the car fall out of the little trap door we made to turn on our light bulb at the top.
My favorite step is the water wheel we created and how we used our minds to create a different solution when we couldn't use the water.
My favorite step is the chemical reaction, which happens in the stomach, because I feel like it relates the most to the human body and hydrolysis in the stomach.
Mine is also the water wheel that we switched to marbles.
And my favorite step is the light bulb turning on at the end.
And mine is also the weight falling down on the front.
I think we're ready.
Sumner Fredericksburg T1 will now have 4 minutes to reset and run their project again. On deck we have our junior team from Mount Air.
about a minute left. Okay.
I got it. I'll grab it. I'll grab it. My dad was as a kid.
Goes right over the lights here. I think so. That's all good. You guys make any changes? Change anything much?
I don't think.
Just retighten
Well,
the
just
knot.
redid the string. I mean, had to fix that. It's not tight on there like it was because it was originally just connected, so now I just tied a knot to the knot that was there to hook the mast back on. But
All right, we're ready.
Good work, Summer Fredericksburg. Now on to our junior team from Mount Ayr. Then we'll finish up our finals round with Saint Ansgar.
Whenever you guys are ready.
My name is Kensington McAllister, and I am a member of the Mount School's 5th grade tennis, which also include Nash House, East 11, Caleb Schaefer, and Kinsel Newton. This is a machine today's body.
My name is Nash Schaefer, and our theme is the human body, and we are telling a story about what happened to Timmy one day. Timmy was walking down a path, which is the ramp at step 1. Then he stuck his toe on a bench, which is the pulley. The pain traveled up the nerve to the spinal cord, which is at number 4. The spinal cord sends the nerve up to Timmy's brainstem, where the book falls at number 5. Timmy's brain received the pain sensor information. Oh, I skipped a step, sorry. The brain stems transmitted the pain sensors to Timmy's brain, which is the balloon blowing up at 6. Timmy's brain receives the pain sensor information and processed it, which is the tennis ball falling. Timmy yells ouch, where the books fall at number 8. Timmy grabs his toe to calm the pain sensors, which is at number 9, where the red ball swings. Timmy does not feel the pain anymore when the bell rings.
My name is Easton Weber, and I am going to tell you about the ways we use the engineering and design process. At first, we had a ramp for the beginning. We fixed the ramp a lot, then we decided to get rid of it. We got rid of it because our ball wouldn't roll down the ramp, even after we made modifications to it. We made changes to our design by making the ramp smaller in size so that the ball would go down and have better guidance. We had made our base too big, so it would not fit in the suburban too hall. So we had to make the base a little smaller. We made it smaller by cutting 4 inches off the base, so it would fit in the SUV. We also determined that the best place to cut the excess from was the bottom of the base. Then we would just flip the base on its side to slide it into the suburban. We wanted to have a book pushing syringe for a chemical reaction, but the book would fall off the cardboard platform. So we made sides on the platform to hold the book into place, and now it works. We wanted the balloon to blow up and knock over the tennis ball, but the balloon was too small. We ended up making the balloon bigger by sizing it up to a 12-inch balloon instead of a 9-inch, so that way it would knock the tennis ball off. My name is Jendro Sanitation, and I will be telling you about how we integrated STEM process. We decided to put chemical reaction into our machine. When we did this, we had to combine mathematical knowledge to determine how much ingredients to use, scientific knowledge to determine what things would react to make a gas to blow up the balloon, and engineering design to put the parts together to make a reaction happen.
My name is Kayla Schaefer, and I will be explaining the machine steps. The first step is the metal ball going down the incline plane. The second step is the metal ball going into the bucket. The energy of the ball moves the pulley and the other buckets go up to the marble run. The third step is the marbles reach the top of the barrier and then go out of the bucket and down the marble run. The fourth step is when the marbles hit the book, causing the energy to transfer and fall on the top of the filled syringe. The fifth step is a vinegar-filled syringe which releases vinegar through a tube connected to a bottle, and the bottle has baking soda in it. The sixth step is that the baking soda and vinegar causes a chemical reaction that builds up carbon dioxide gas and blows the balloon up, which knocks the tennis ball over the tall platform. The seventh step is when a tennis ball falls, it knocks over the books. The eighth step is the books falling and pushing the rubber ball into the dominoes. The ninth step is when a rubber ball hits the dominoes and it causes them to fall over. The 10th and final step is when the dominoes fall on the top of the bell and ring it up.
The biggest challenge we faced was time. Our school had a lot of school canceled because of snow. So we got behind schedule and had to arrange extra time for our typing to finish our project. During the last 2 weeks, we had to talk about prioritizing what was most important. We decided we just wanted the machine to be finished and achieve to bring to the competition. We did not care if we had to touch it some to make the reaction work. We had to sacrifice perfection to just get them done, and that was kind of like the right brothers we learned about last year. Their first flight was in 12 seconds, and the plane was far from perfect, but it made history and did what they wanted it to do. We were like the right brothers. We will keep making improvements to our machine over time if we qualify for nationals.
What's your guys' favorite part of the machine?
Mine is probably the chemical reaction.
Same.
Yeah.
What did you learn new?
Probably the chemical reaction, like the baking soda and vinegar.
What did you learn about yourself? Anybody else wanna? What did you learn about yourself and how you work with others?
People work faster than others.
Yeah. Some work faster than others. Okay. Thanks. Anybody else? All right, whenever you're ready.
exploded. Yeah.
All right, great job on there. And everybody said here, St. Ansgar will be up next to finish off our final round.
Knock the book over, you can't push that one or it'll completely. Yeah. Also, there's a way you guys. Other marble. 1 minute. I think it's fine. No, you're fine. Yeah. I like the way it kind of slanted. It looks really good. Look at the picture. This is really
As not reset, just remind everybody when St. Ansgar finishes up their second and final round, we'll be ready to eat lunch right away. We have the commons and eat, and the judges will convene to go over scores. Teams can start tearing down their projects at that time, and when the judges are ready, we'll give out our awards.
Push the book as hard. Do we need more chocolate?
Do you need to go get a dog?
I think you got her eyes. Ew. Oh, where's the chocolate? Ew, it stinks. We need more vinegar. Hey, Kinsey.
is Mac Veland.
I'm Hannah Clevenger.
I'm Ashton Paul. I'm Kaylee Hickman.
I'm Kinsey Anderson.
I'm Morgan King.
I'm Alex Lenz. I'm Drew Powers.
I'm Carson Sparrow, and we are
The Medical Mob.
Our project starts with the systems that supply us with what we need. So in our bodies, this is the veins, and in our communities, these are our piping or water systems. So we start with the PVC, and water will flow through that, which triggers the next step, raw blood just going through the veins. And to advance technology, we can make our piping systems more like veins with more twists and turns to have a more efficient use of space.
I have the second step, and my step is the mouth. And this step starts with the water from the previous step pouring into my cup from this bowl. And then it tips over and falls onto the cotton candy. And in advancement of technology, we can make food packaging dissolvable like cotton candy so it's more sustainable.
I have the digestive system, so once the saliva falls onto the cotton candy, it dissolves it, allowing it to break down into smaller pieces of food, which then travel through the digestive system and fall into here, which shows us absorbing nutrients and giving energy, allowing us to open the meat. Through digestive waste, we produce methane, and this can be used to help advance technology by using it in our everyday homes.
I have the next two steps, and they're based on the knee. I chose to do this because I had 2 knee surgeries in high school, so I thought that would be fitting. As Kinsey said, my step begins when the teeter totter opens and the knee opens. The ball on the bottom of the knee sets off the mouse trap and pulls that pin, and then the ball rolls down the ramp and hits the door. The door and the knee are related because they both use a hinge movement, and that can be used in making braces for athletes who've been injured better.
My step begins after the bottle falls over. This represents the lungs within the human body. It says it inflates and deflates just like the lungs do. Within the balloon is the baking soda, and this combines with the vinegar, and this is our chemical reaction. This inflates the balloon and knocks off the weight. The weight then pulls out a pin that's holding up the balloon ball. This is our fluid power step. There's a little launch pad at the bottom that's compressed, and this causes the air to go through the rocket and up to the top of the machine.
My step begins when the ball rolls down the ramp. It's the guy and goes down, it's the switch, and then there's a motor that turns on, which pulls the scissors open, which releases the next step. The tube represents copper pipe, and the guy represents the work that we do every day. And he has some 3D prints that I designed, which are like magnets. You go through the copper pipe, they generate electricity to be used by the electrical step.
The yellow pendulum is a ray of light that will hit the cornea of the eyeball, and when this happens, that's how we see the world around us. So after the eyeball's hit, it knocks the switch over, which will turn on the laser, and using the law of reflection, it will reflect off the mirror through an eyeball and will pop the balloon. What if we could see whole images just from a technological ray of light, like this laser goes to the eyeball? This would be an advancement to technology because we could see images without using a screen.
As the balloon pops, it's holding marbles which fall down through the vocal cords. The marbles are representing air molecules which hit the tuning forks, which create longitudinal waves, and it vibrates the air around them, creating the sound you hear. This can be used to make an advancement in technology that can read brainwaves. This will help people that can't speak to others have the ability to communicate through their thoughts.
Right after the marbles go through the chime box, it goes into this cup and it breaks the cup down, making the stylus go up using the string and pulleys assist in that. And then the stylus is pushing play on my phone. It won't actually play until it lifts up though. And when it plays, it'll play the song Branch 2 right before the brain step.
My step is the brain, and it starts over here with the cup of marbles falling onto a battery, which turns the switch on, which will then turn these lights on and will light up the light bulb in the brain. The brain lights up with ideas like it's a light bulb, and all of our steps show advancement in the human body.
Which part do you guys struggle with the most to get to work every time?
The electrical step with where it starts there and then going to the laser was hard to do, and we kept messing up little parts of it, which would throw off the whole thing. So that one was probably the hardest to get right.
What part of the project was the most fun?
Kind of like figuring out the music step at the end, hearing that play. We thought that was kind of cool.
A lot of your components are recycled, but what components did you buy and why did you decide you had to buy those components?
We did buy a laser. We had that idea that we wanted the laser to represent a light, so we didn't have one that was strong enough to pop a balloon, so we did have to purchase that.
We bought the spray because we didn't have one, and I wanted to be able to like stuff it with lights, and we didn't have one.
All right, we're ready.
St. Ansgar will now have 4 minutes to reset for their final run. As soon as that's wrapped up, everybody can head out to the commons for lunch while the judges deliberate, and then we can start tearing down projects.
Trying to sleep.
Don't turn the break.
Is this good?
Oh, did you restart the sound?
Yeah.
Should we move the pendulum more in, or should we leave it there?
I think it's good.
Good?
You think so?
Is this good person?
Good?
Did you guys make any changes or adjustments?
Well, we tried moving the pendulum to make it more straight. I think it might have been a little crooked last time. Okay. Good?
final run-throughs. We can head into the commons for lunch. After that, teams can start tearing down their projects. The judges will tally the scores. We'll give awards after that.
Still going.
It's live right now?
Yeah.
How did you feel the engineering design process was?
The juniors?
No, the engineering and design process.
I don't. Pretty good. All right.
Did you watch it?
No. Yeah.
Doing? No, not your bruh. It's just so sad, Kelly.
Oh well. So I guess we can just plug it back in.
No, Taylor, where's it plugged in at? Oh, just plug it back in. No, we don't need it. The mic isn't.
I'm glad you guys did it. Yeah, we'll probably be back.
Yeah,
I
and
hope
if you're not, I'd be happy because I'd love to get something going in Central Iowa like this. Something for juniors and or seniors. If you ever want any information or whatever, I'd be happy to send everything to you. This is the first year we made awards where you can purchase them.
they look like they were
They were,
They're cool.
cheap and
Yeah. And this is probably your burner.
yeah, I'll raise some from the shop or use it all.
Yeah, it's perfect. It's a good project for the kids.
Absolutely.
Yeah.
Well, thank you.
Yeah, thank you.
Pretty good, Mr. Clevenger. Pretty good.
Summer Freddy's didn't do pubs on finals. I thought that first one, I thought, oh, that's really good. Awesome.
You got a neat project.
Who's the winner?
That's a good question.
What do you think? The Journal plays a big part.
Journal plays a big part also in the league. I think it'll be this project as well.
Yeah.
I don't think their journal is quite as good. But I like theirs. Who was head coach story? When Hancock storyline was really good.
Yeah.
I like that. I think we got good chances anyway. But I don't concern myself with winning it, just doing the best we can.
Well, when's the last time we won? It's been a while.
We actually won it last year.
Oh, we did?
Yeah. So, but they had a good project too.
Mom, my mom.
Sure. I'm sure she does. I think you're live on TV there, Grover, so be careful.
Wave at my mom. What are you
What do we got? Like get a picture of Drew?
You taking a picture of me?
God, get that Drew.
That's going on Facebook. It's going on the books.
Oh.
On the Facebook. Thank you for your support on this project, Grover.
It's a good day.
It's a good day.
It's a feather.
I don't know why we can't do
It's
it.
no work that you do, but it's a feather in your cap that you can go to the superintendent's meeting and say,
Yeah.
we recently held an engineering design contest.
Put it on my resume. How about that? For that next job. Oh, that next job's retirement.
Schools from all
Next
over.
job is sailing off into the sunset. I'm saying. Amy who?
Oh, you'll remember.
I don't know. I was wondering that when I came in. I'm not a micromanager.
How's the pizza, guys? Pretty good?
Are these guys too good to eat in there with everybody else?
Did you guys get some to eat?
No, we're good.
No, there's plenty in there. Sure? Yeah, plenty. Go grab some. Or else we're sending pizza home with you.
I have no leftovers tonight.
Did you? From last night's Super Bowl party?
Man, it was awesome, wasn't it?
If the Niners would have won, it would have been perfect.
I would have got so much crap. That would have been the worst.
Oh, I want that. Not that I don't.
I just don't know. I know how I hate it. I didn't want to see him in there. I get it. I get it.
Completely on sound. What's her name?
Hey, Jay.
Kachava?
Except at least our coach has personality, right?
It's on. It's on.
Drew. At least.
Yeah, the mic's on
Who
right
was
now.
it? Dr. Or the watch face is
good though?
These coaches, they don't You can stand there. Let's demonstrate it, and you're going to go right over here. Right over here. Yeah.
I see the outside. I walk my house, but I
think in March. Maybe we'll get a meeting in March. That was the first one to drive the bus. I know. He wants to know more.
I know. I said, where are you going those days?
I can drive it. He's not nice. See, they have like lights on before we started the next day, we could bus there and see how much they can do a good job. If we didn't go tomorrow, we need to pay whatever they're all using. If we didn't put a bus in, we got to so you know that shit. Yeah. Look at the muscles on this girl. All the way from Mount there.
I don't know anything down south. You missed it, and something like that. And it just like.
I've refereed umpire. When I was in college, I was in south. It's in the southwest corner.
I like it. Oh, careful with the camera. Nice job, you guys.
Good work, Randy.
I don't have eyes, sorry.
Nice job.
Nice shirt.
Yeah,
Down on Highway 2, it's down.
No.
Lincoln, you better go talk to that kid that had a t-shirt on. He's smart. Maybe he gave him $1. We should go over there and show him how to mop.
No, I don't know how. Devin does all our mopping.
For our supervising, it's a big day.
So ready for Drax's supercar. No doubt.
He's got, well, and that's like, because then kids, it's like, here's the book.
Alexa. Yeah. And then.
So we'll see. First time.
Yeah, dog is insane.
Thanks to all of our teachers and sponsors who put teams together, came and participated. I'd like to thank Dennis Treesoff from Saint Ansgar, Amy Price from Summer Fredericksburg, Lynette Schreiber from Rockford, Susie Carlson from West Hancock, Brian Taylor at Osage, Derek Greenland at Mount Air, and Mary Beck and Mark Lynch, who is here with us today from St. Ed's. We also want to thank all of our business sponsors who make this possible. The Housing Community Endowment Foundation specifically, and all of our schools for allowing us to participate. We'd like to thank our administration and staff for supporting this event here at Saint Ansgar as well. Now we'll go ahead with our judges pick awards, and then we'll get into the final competition awards. First, the theme award, which is for the team that best identifies and communicates the competition theme, and that is Sumner Fredericksburg Team 1. Come on out and grab your award.
Stay right here.
Our most innovative step for the team with the most creative or genius step transfer of energy is Sumner Fredericksburg Team 1.
I think you're good.
The recycle above and beyond for being the team whose determination to use recycled materials was commendable, West Hancock.
Good job.
Heavy award. Got it?
The College and Career team that exemplifies skills that apply knowledge, effective relationships, and workplace skills. Saint Ansgar.
It's the one that says college and career radio. There you go.
The People's Choice Award, which is, it looks awesome and it was fun to see run. And there was a three-way tie actually in the voting between Saint Ansgar and Summer Fred. So they put the names in the hat and drew one out, and for God's Saint Ansgar won.
Good work, buddy.
The best technical construction for a machine with the best overall construction, fit, and finish was also a tie between Summer Fredericksburg Team 1 and Saint Ansgar. So again, the names were thrown in and drawn, and Saint Ansgar won that
Good job, Drew.
We definitely want to recognize our junior team that was competing here today. We had the one junior team that did an excellent job. Elementary team winners all the way from Mount Air. We appreciate them coming out. So our junior award winners are Mount Air.
Good work, team.
Okay, now we'll get into our final awards. In fourth place, Wes Hancock.
Have the fourth place go? Because fourth place is a crisp high five.
In third place, Summer Fredericksburg Team 2. We do have awards for these.
Good work.
Our runner-up this year, Summer Fredericksburg Team 1. And this year's engineering design competition champions, Saint Ansgar.
There you go.
All right, this wraps up this year's competition. Thank you so much for everyone who participated and helped make this opportunity possible. See you next year.
Yes.